Thank you. Can you guys hear me? All right, cool. All right, car hacking basics. Hexadecimal OX05. Anybody know what that means? It means 101. It's a 101, guys. 101. It's my awesome binary to hex conversion. I thought everybody would get it. Sorry. It's awesome. Okay, so let me just tell you a little bit myself, because what's the point of doing these things if you're not going to prop yourself up a lot as much as possible. So I started a company called CAN bus Hack back in 2010. Basically, I was laid off and didn't have anything better to do. And I like to hack cars. So I started CAN bus Hack. We started in Ferndale, office in Ferndale. Now we moved up to Orion. Here's my email address. My name, Robert Leale at canbushack.com. So if you need to get a hold of me, also you can go to my webpage. Even during this talk, if you feel like it, take your phone out. If you're done playing Pokemon Go, you can check it out. I think there's actually a Pokestop right by my office. So if you guys are bored, it's right there. It's so convenient. So it's very helpful. So they gave me a 30-minute slot. Probably going to take all of 15 of it. And then we'll have time for questions and answers and stuff like that. So I'll try to move. I move pretty quickly through it. A lot of this, Atlas was kind enough to talk about, so I'm going to be unfortunately reiterating some things, but in a fashion unique to myself. And so we're going to talk a little bit about, yeah, exactly, funny is the difference. So we're going to talk a little bit about networks. Let's talk, because you're going to start with basics. We start with networks, because that's really my focus when I'm working with vehicles. Is I like to work directly with the networks themselves. You can work with controllers. That's fun, interesting, but a lot of the fun happens with the communication between the controllers. And there are a whole bunch of different standards, different networks, and depending on what year your vehicle is, and I'll talk to you a little bit about how you can figure it out yourself. So this is really for you guys later when you get back. You can get back to your car, or your parents' car, or your sister's car, and hack that car if you don't want to hurt your car, or your motorcycle even. Some of these motorcycles actually have CAN bus on them now too, so talk a little bit about that. So if you want to, hopefully with the information you got today and going to my website, you'll be able to at least get started in hacking your own car or your neighbor's car if you want to. If they give you permission, that would be nice. Pretty good idea. So K-Line. It's really kind of where it all started. K-Line is the fundamental network, and it's really old. Very few OEMs still use it. So it's still in use. It's very inexpensive, so that's the reason why, because cost is always important. And then we had JT50, which Atlas talked about, the VPW and PWM, which were different variations on the same standard. And old again, not very many cars use it. Ford and GM were primarily the main consumers of VPW and PWM. Now we have CAN bus, which is old, technically, but it's not busted, still being used, and I'll talk a little bit in detail, actually in a lot of detail, how CAN bus works, and I'll show you some examples of CAN bus messaging, and we'll talk a little bit more about how you guys can use CAN bus messaging and maybe do some simple controls or even read data from your vehicle itself, so something very simple. FlexRay is relatively new. It's a network designed to help solve some of the problems of CAN bus, some of the security issues of CAN bus. FlexRay does solve, but mostly it adds redundancy and speed to networking in vehicles, and is currently used on a handful of vehicles. Most notably for me, anyways, is the Infiniti Q50 uses FlexRay for their steering by wire. So the only car currently that allows you to actually, can be physically, mechanically disconnected, and the steering wheel is not actually controlling the steering the wheels. It's a motor that does it, and it's sort of just a joystick input, if you will. And it uses FlexRay because of its safety features and security features that they've added to it. So it's really nice. MOST, which is media-oriented system transport, it is Still being used. I thought it was going to die, and maybe it will die soon, but GM just added it to some of their trucks, so I'm not really sure if it's going away or if it's staying, but it's another sort of higher speed serial data network that allows for up to 150 megabytes. That's right, megabytes of data, which is a lot for an automotive. Just inside of your car, you want to transfer video, it will do it, and that's what they're using it for. Is just for video between controllers and things like that, so that a display can be remote essentially to a controller itself. And then Ethernet, which thank you, they're finally adding Ethernet to cars. They've been talking about it for a long time, and now it's really happening. BMW being one of the first ones to add, a standard Ethernet, and then later we'll talk about the variations that they're adding as well. So let's talk a little bit about ECUs, or engine control units, electronic control units. So there's a lot of them in your car. You might have a body controller, a window, a driver door controller, a passenger door controller, a shift interlock controller, your cluster, your head unit. You have maybe a rear body controller, your OnStar or your telematics device. So you can have any number of different controllers, even to the point where I've seen in some Ford vehicles, they have little tiny, they're little LED lights, that PWM lights that change the colors and intensity. So it might be blue or red. It has a little controller on it, and it's connected through a network. So all of the lights, even the lights to the point, are even controllable. And which, if you're going to have fun, if you want to control the lights and the pattern in which they go, you can do that. The headlights, all of the lighting can be a lot of fun as well. And there can be loads of ECUs. 10 is probably the minimum, and you can get up to 40 if you count those little tiny ones. Maybe you got 60 in your car. Who knows? Depending on what you call a little electronic controller. So there's a lot of different controllers on there, and really, the goal of each controller is to essentially physically connect switches to motors, right? Or physically connect inputs to outputs. So if you want to roll your window down, you hit that switch goes to a little controller. That controller is directly connected to a motor. But if you want to roll the passenger window down from your driver's side, that switch goes to the controller, sends it over a network, goes to another controller, that controller then sends it over to this controller, and then the window goes down. And hopefully it's fast enough that there's no latency, so the user, when they hit that switch, the window goes down very quickly afterwards. So as you can see, there's a lot of different features there. The other part of a controller, maybe a more advanced controller, is your engine controller. What does it do? It fires the individual cylinders inside of the engine as well. So there's a lot of different features that these controllers have. They might be controlling motors, windshield wipers, and taking inputs from switches. And it isn't necessarily the same controller that has the input from the switch that does the actual output. And that's where a lot of the fun comes in. When the systems are integrated over a network. Whenever the switch is remote from the motor that actually is controlling it, usually there's some sort of command that happens over the network. And when there's a command over the network, we can insert our own, essentially. So that's a lot where the fun comes in when you're hacking your cars, or your friend's cars, or your sister's cars, or your ex's car. No. So you get the idea. So it all starts here, a lot of the time. So a lot of the OEMs have all of their networks conveniently broken out at the OBDII connector. Not all of them, but many of them do. And I'm sure after all of these things that are happening, this will be very soon going away. But today, a lot of OEMs still have this. I'd say a good 50% of them still break out all of their networks to this connector, which is the OBDII connector or J1962 connector. It's a 16-pin connector. Not all pins are populated. And this is actually a very important point, because when you look at this connector, I usually, when I get into a vehicle, the first thing I do is take a picture of it, just to see what pins are populated, because this will actually tell us what networks are on it. In my next slide, I'll go over that. So what networks are potentially available to you. So you can see, oh, this one's got a high-speed CAN, or this one's got a single-wire CAN, or this one's got a fault-tolerant CAN. You can actually tell based off of this connector, a lot of that information. So that can be very useful for you as well. It's really there for diagnostics, right? That's its legal reason. That's the reason why all cars 1996 and newer have this connector. That are sold in the United States and even in Europe have a very similar connector as well. I've seen it in China now. So a lot of the other countries also have a very similar connector. A lot of them are purple, not black like we have here in the U.S., but it's usually located usually within a meter of the center of the driver steering wheel. So it's in other words, it's reachable from. So if you're a tech that's trying to solve a problem on a vehicle, you can plug the tool in somewhere within the steering wheel. So it's usually underneath. It's called the driver's kick, right where kind of where the well where your feet goes in when you're driving. So that's where you find it. Just go up underneath there, get a light, you'll find it. Sometimes it's hidden between an access port. There might be a panel that you have to pull down, but usually it's labeled OBDII, it'll say on it. Ford has that a lot. They're really easy to find. There's also websites out there if you really, really are stuck and you can't find it. There's websites for OBDII locators and things like that. It'll help you find the location. So what's on it? The connector itself, I know it's kind of a little fuzzy. The connector itself has multiple pins here. So this is pin 1 up here, all the way to pin 16 down here. So if you saw something in pin 2, or if you saw something in pins 6 and 14, you could actually quickly tell what kind of network you're connected to. Like this example on this, as pin 2 is populated. So that's J1850, right? So this particular vehicle has J1850. There's 2 versions of J1850, VPW and PWM. If it had 2 pins, then we would know it was VP or PWM, I think, off the top of my head. And then this one is essentially it's GM's version, because this GM J1850 was just 1 wire. So that's a 1-wire connector. It has ground here, 2 pins of ground, a chassis ground and a signal ground, and then 12 volts or VBAT, if you will. And so you can actually run, that's got power all the time. So if you want to put your cell phone charger on your, make an adapter, you certainly could and run all the time. So if you're ever looking for power. And then it's got 2 other pins, and these 2 other pins are actually discretionary. So there are some that are not discretionary, like 2, 4, 5, 6. All of those are fixed. They must be this. And then the other pins are what's called discretionary pins. So the OEMs themselves can put whatever they want there, and they do. They put whatever they want. Sometimes they put ignition, like if the ignition is on, it'll be 12 volts on a particular pin. Sometimes they'll put the vehicle speed on there, so it'll just be like a pulse of as the wheels spin, they run by a little sensor, and then every time it rotates, you get a pulse. Sometimes you see engine speed up there, similar idea. It'll just be a pulse output. Up to other networks. GM uses pin 1 for single wire CAN. Ford uses pins 3 and 11 for a secondary CAN bus. So you can get other CAN buses, other things like that. So there's a lot of different information that you can quickly discern from this connector. Question? Sorry. So with this connector, if you see it and you're on a GM and pin 1 there's something in pin 1, it's single wire CAN. But if you take that over to a Fiat, the 500 is a good example. The Fiat pin 1 is not single wire CAN because it's a different OEM. So each OEM has sort of a different look for this connector. And their motivation behind it is really quite simple. This is their port. This is their interface for their scan tool to plug into their cars, right? And so all that discretionary pins are going to change because the OEM has a scan tool that is expecting certain information or certain things to be on these particular pins. And so it's for them. And so the way they'll move is between, they'll try to keep it the same across all of the vehicles that they manufacture. Which in turn, if you think about what that means all of their scan tools have an interface port. And so if they wanted to change this, the cost would be immense, right? If they wanted to move something over for a different pin, well, they'd have to change all of their scan tools, and that could be $1 billion, you know, just to make one change on this port. So they're very cautious, and it's very difficult for them to make changes on the port. So it can tell us a lot of information about the vehicle itself. So a little bit more technical. There's LIN bus as well. So if anybody here is familiar with CAN bus, which I'll talk about later, there's also another network that I like to use. It's very hackable. It's a lot of fun, and a lot of the new vehicles, their starting systems use LIN bus, and a lot of their lighting controls and things like that. Usually LIN bus is not broken out to that OBDII connector, but it might be broken out to other connectors in the vehicle. So you can find this network as well. And what's nice about LIN is it's very low cost. So you can find an Arduino, any kind of standard one wire. It's a one wire UART. So if you have a UART on an Arduino, to make a circuit to turn those two wires into one, there's plenty of examples. If you have something that has K-line on it as well, it's also very easy to interface with as well. It's just a 12-volt standard UART that runs typically between 10 kilobits to 19 kilobits per second. So you can hook it up to your computer and at least monitor the data. Sending the data is a little bit more of a challenge. You'll have to write some of your own code, or you can buy tools that do it for you, and I'll talk about tools a little bit later. But LIN bus is really quite an interesting network as well, because it's relatively new, but it's using old tech, so it's low cost and easy to enter into, and you can get a lot of different control done with the LIN bus. And not very many people talk about it, just because it seems so basic. But if you're trying to hack your car and try to have fun with it, if you want to, maybe turn individual lights on, or get switches, a lot of those little switches, like your driver door, window switches and things like that. If you want to do controls, they're typically going to be over LIN bus. I have some customers that use LIN bus for turning the windshield wipers on. If you want to turn the windshield wipers on, LIN bus is a really good way to just activate those features effectively. So LIN bus is kind of unique. There's one frame. The frame, similar to CAN bus, holds up to 8 bytes of data. And it allows you to send a message to a controller as a master, and then the slaves nodes, the other nodes on the bus, will respond inside of that same frame with their data. So it's a little bit of a challenge when you're working with it, because if you want to send data on LIN bus, you have to sort of cut the master out of all communications and then sort of simulate the master's messages. So that's the only challenge with LIN bus, is that it does involve usually removing wires from either a connector or cutting the wire specifically. So be very careful when working with LIN bus in that regard. So the master does need to be removed when you're doing it. Ethernet, which is something honestly I don't have enough experience with to be really even talking about it. But I can talk about what I can look up online and tell you guys a little bit about it. Ethernet is now coming to vehicles. It's very, very new. We know that the Tesla has it, but a lot of the Ethernet that we see in vehicles today is your standard Ethernet that you can plug into your computer. But they're changing that. They're changing that in vehicles right now. They're making their own Ethernet, because 4 wires cost twice as much as 2 wires. So wire reduction is huge in vehicles, because they have a lot of wires. As much as they can reduce, if they can reduce 2 pennies, they'll do it, because that saves hundreds of thousands of dollars, right? Per model year, something like that. So the pennies cost a lot, and 2 wires cost a whole lot. So they're reducing it, and they've made this one pair Ethernet open group, and you can go to opensig.org and actually get the spec for it as well. I didn't talk about that with LIN bus, but if you wanted the spec for LIN bus, that's also free. LIN Subbus.org as well. So some of these specs are free, which is nice. It is based off of standard Ethernet, 802.11.3. So if you get an adapter, for standard Ethernet to open Ethernet, you can actually send and receive data on Ethernet. What that data will be, it's not going to necessarily be TCP/IP packets. It might just be proprietary data that they ship. It might be their own proprietary protocol, which is very common of OEMs, just make their own proprietary protocol. So a lot of research still needs to be done about the security of these protocols and if they're effective. I think they use standard Ethernet, so for MAC address. So that layer still is intact. It's just that high-level protocol, whatever they're going to use, they can use whatever they want, obviously. Sometimes they use TCP/IP and I have seen CAN bus traffic over TCP/IP, so they'll repack CAN bus using their own proprietary protocol. So, and that's my very limited entree into this because it's very new. Like cars that are coming out with it they're just coming out or they're really expensive to buy right now. So I just haven't, but they're coming out now. 2 wires, and they're going to. So this actually this supports up to 100 megabits per second right now. I think it's the max. And then they're working on a gigabit as well. So they'll have a two-wire gigabit coming out, and then probably a few years as well. So we'll see it in cars in probably 8 to 10 years. So they're going to have, big pipes. They're going to connect the telemetry units with the head units so that they can do over-the-air updates, right? I mean, that's one of the big reasons is reflashing. Because of all of these, because of the problem of CAN bus, it just takes, if you get in your car, let's say you wanted to get a new back up. You get into your car, you turn it on, it says, hey, I got a new update for you. Would you like to apply it? And you hit yes. Then you have to wait 30 minutes for it to apply. People are not going to be too happy. They're not going to hit yes next time, right? So we really have to have a fast pipe that's going to allow us to send that data as quickly as possible between the controllers. The other option, the OEMs have 2 options, right? They can have all of the firmware stored on one module that has enough storage capacity so they can reflash other controllers, or they have to, sort of cache it on the actual controller itself, which requires twice the amount of storage so that it can be quick. So they have these challenges that they have to deal with. If you make it faster, then we can update it. And so that's the reason why they're doing that right now is mainly updating and large amount of data. Now, of course, you can send video. There's some ancillary features that you could add to it. You can send some video, but not very many people use video in everybody's using video on their phones or on their tablets. It's not such a big concern. Nobody's knocking on their door and saying, hey, I really need that video in the back seat, all wired. That'd be great. You can still use wireless for video. So the reason why they're doing it is just mostly for updating firmware. It's like the number one driver, I guess. And why would they need to update firmware? It's not like anybody's hacking this stuff, right? So that's probably the main reason. So let's talk a little bit about CAN bus. It's a little bit technical. Sorry, it's a little dry, but CAN bus is controller area network, as we talked about earlier. There's different baud rates, but you can see it typically goes up to 500 kilobits per second. So it's not super fast, right? We don't have super duper high speed with CAN bus. What we have is high reliability and short packets, really quick messages that deliver the information and then shut up, right? Here's your data, real quick. What's your engine speed? That's it. Really small packetized pieces of data that don't need to be big. They don't need these large, there's not long messages, not very verbose, right? And because of that, you have to shorthand a lot of the information, right? Everything needs to be shorthanded. You're given 8 bytes to tell everything you need to say about the status of this particular switch, or this motor, or this. And really, you have 8 bytes, that's 64 bits. If you can put it in 1 bit, put it in 1 bit. If you push the down button on that switch and you can fit it in 1 bit, or if you open the driver door and you can fit it in 1 bit, put it in 1 bit. Because we have 4 doors, plus the hatch, plus the hood. Let's put them all into 1 bit instead, each. And so because of that, we find that everything is really small messages, really quick, simple, and very, very, very efficient at the end of the day. But with efficiency, we lose that security, like we were talking about earlier. So if we wanted to insert our own value, so if a CAN bus message is sent on the wire and you wanted to send your own version of that exact same message, it can be done. And that's the challenge with CAN bus. So there are ways of mitigating that, and we've seen, you can sign the message, but you only have 8 bytes. So your signature's got to be really small, right? Very small. 8 bits of signature. It's a challenge to really secure that, but you could. But that's sort of what some OEMs have to do now, is they put small signatures on them just so that's it's more challenging. But replaying them is still very much a possibility. But if you want to change it, it's a challenge. So when we have it's a multi-master network, that means any node at any time could send a message as long as the bus is free, right? So that's the challenge, right? So if you want to secure the medium, it's not possible. If a message needs to be sent, any node's allowed to send at any time. This is just a fundamental feature of CAN bus. There are 3 different flavors. So when a lot of people, when they talk about CAN bus, they're often talking about ISO 11898-2, which is dual wire CAN. But there's single wire CAN and fault tolerant CAN, which are used for body networks on not a lot of vehicles. GM and Honda use single wire CAN. Honda's moved away from it, but GM still does. And then fault tolerant, we see that on the Fiats and a lot of the European vehicles had that for a while. They've also moved away from it as well, and are staying with dual wire CAN. I don't have a slide here with it, but they're coming out with a new version of CAN bus. It's called CAN FD. Because 8 bytes isn't enough, they're increasing the maximum size up to 64 bytes of data, but they're changing the baud rate mid-message. So the beginning baud rate is 500 kilobits, and then you switch over to 2 megabits, and then you're back to 500 kilobits. So it's kind of it's just they're keeping the frame duration the same. It's just they're just increasing the baud rate during the data portion of the message itself. So let's talk about the message frame itself. So again, 8 bytes of data for CAN 2.0, 64 for FD. We have 2 identifiers. So sometimes you might hear about the 11-bit ID or the 29-bit ID or the extended ID, sometimes it's called. That's really used to add more information about the message or about the data itself. So they'll add like who the message is from inside of the 29-bit or something like that. So the frame is really very simple, and that's it. Like if you guys look at a TCP/IP, like if you guys are familiar with that, if you look at that, it's each thing, it's just a bunch of bytes. Just here's 8 bytes, here's 8 bits, next to 8 bits, next to 8 bits, and 8 bits, and that's it. CAN bus works fundamentally a lot different. It's not 8 bits next to 8 bits, except for in the data portion. Otherwise, there's just individual bits that describe the arbitration ID, which is next to how big the frame is going to be, which is next to the data, which is next to the CRC. So it has a CRC inside of the frame itself to help verify that the data that was sent is the same data that was received. And then it has this thing, which is very unique to CAN bus, is this ACK, or acknowledge field. And so I'll go over it real quick. And it makes it really interesting when you're working with CAN bus, because especially if you're new to it, this ACK field, essentially allows all of the receivers to notify the sender real quickly that, yes, I received the data and I received it correctly, right? Essentially what happens after the transmitter sends the data, there's a spot inside of this field where the transmitter is now a receiver and the receivers are now the transmitter. And what that does is all of the receivers will just essentially raise their hand and say, yes, I got it. During this 1-bit time right here. Boom, they'll just all say yes. But if one didn't get it, it will then, at the next part of that bit, say, no, I didn't get it. So it'll essentially say, that's its chance for all the other nodes to say, the ones that didn't get it, to actually say no. The ones that respond in the first bit will say yes. The ones that respond raise their hand in the second bit, they'll say no, I didn't get it. And what happens, and this is where it's really, really crazy at a very, very, very fundamental level with CAN bus, what happens is the transmitter will throw that message away that it transmitted. All of the receivers will throw their received message away. They'll notify the application, hey, I got an error. They won't tell it what happened. All of this data is just thrown into the garbage bin. And the application that was monitoring it will have only limited information as to what was there and why it happened. They'll say, oh, somebody didn't get it, so don't worry, the transmitter is going to resend it again. Okay, well, guess what? The transmitter can only do that so many times before it will stop. There's a little fault containment. And so if you are a skilled hacker, you could just assert that bit every time that that message was sent. Assert that bit for, like, as a receiver, you're allowed to do that. Just assert that bit. I didn't get it. And then after about, 127 times, the transmitter will just give up. And then you can send your own version of that message now. So it's a little bit more, you talked about, hey, shut up. It's like, everybody ignore this guy. I'm gonna take over. You can totally do that as well. So CAN bus has many different inherent problems that if you understand it at a very low level, a physical layer, it can yield some pretty interesting results. And so sometimes we have to use that. Now there's some obvious side effects when you do that. You can't just do it to the one message that the controller was sending. You have to do it to all of its messages in order to get it to shut up. But, if you can do it to one, you can do it to all. So that's not that big a deal. So let's talk a little bit about diagnostics, because before I was mentioning, you got a command here, you got to send a command, you want to receive a command. Diagnostics actually is a little bit more of this is what the techs use. Like if you go to a dealership, they have a diagnostic scan tool. And what this diagnostics, what it allows you to do is actually be a tech, right? You can go buy these scan tools. You can go to eBay, get a tech scan tool, and do all of these features. So there's aftermarket scan tools that incorporate all of these features as well. But what that allows you to do is do what's one of my favorite things is input-output control. If you want to turn the windshield wipers on from the CAN bus from the diagnostic port, just send the request. And what's crazy is when the OEMs finally start locking us out of the normal messages that are going to turn the controller on, they're going to have a real difficulty locking this part out, right? I mean, it's going to be a challenge because they need their techs to also be able to do these diagnostic controls as well. So it's a big challenge they have to weigh the benefits. There's always a way, essentially this is a feature that they've added on purpose, and they want their techs to be able to plug into that diagnostic connector and send these controls. So what can we do? Potentially we can turn the windshield wipers on. Okay, that's boring, No, what's really interesting, you can turn the windshield wipers off. Not on. Who cares if you turn them on? You can turn them off. Somebody's driving down the road, windshield wipers on. I don't like that. Turn it off. Okay, well, it's not raining, so what's the big deal, right? It's not raining. You can turn the windshield wipers. Well, actually, you can also control the windshield wiper fluid if you're bored. Just turn that on. Well, I'll just turn the windshield wipers on. No, you won't. I turned them off for you. So there's some real challenges from that connector itself that when you're driving down the road, so just be aware of it. And how do we fix that? Do we just stop diagnostics? That's the thing. Like, can you just stop the ability for the user to do diagnostics? Oh, well, we can just limit. Right now, the challenge is if I am a user and I do an input and I try to turn my windshield wipers on, the diagnostics has priority. And so maybe we just change the priority system. So now the user, if they turn the windshield wipers on and they change that switch, it actually overrides the diagnostics, which is probably a good safety feature. So the thing is we're at the mercy of the controller software, right? Whatever software is in there, who's validating that it does that, right? The OEMs come up with a spec, they give it to their supplier follows the spec, they give it back, the OEM tests against the spec that they did, but did they put in their spec, hey, priority goes to the user? Typically, no, they're not thinking about it. So we just had to remind them a little bit. Sometimes that's helpful. But if you wanted to do it on your own car, it can be done. It's a lot of fun. Lock and unlock are also available if you want to, build your own little lock and unlock app on your phone, which I did, which is a lot of fun. Just for myself, just press a button, Bluetooth, unlock your car, all there. Commands are often in sequence, so a lot of times you might, especially with diagnostics, you might have to tell the car, go into a diagnostic mode, then tell it to do this thing, and then exit that mode. Sometimes it's necessary as well. So often the sequence, and I'll show you something else that you can do with diagnostics. Let me see if I have it up here. Should I bring it up? There it is. So another thing that's kind of cool. not just can you do certain commands, but let's say you were savvy enough. Okay, load problems. Oops, wrong one. Simulation. There we go. I gotta turn this filter off. Just so of course. I did it yesterday. There it goes. Simulation, browse. There. I'll try it one time. If it doesn't work, oh well. Oh, you guys can't see it. All right. Well, it didn't work anyways, so. Essentially, if you wanted to, part of diagnostics is not just I/O control, but reading memory, right? So if you wanted to dump the firmware, something fun to do, you just ask it, hey, what's in memory address, OX800000. Could you give that to me? Oh, here you go. Give me 5 bytes of it. And then give me the next 5, the next 5, the next 5, et cetera, et cetera. And you can just walk memory. You can see what's going on in RAM, what's going on in ROM. Not all vehicles allow you to do that, thank goodness. But a lot of them do. And it's usually the higher end controllers, the ones that you're really more interested in anyways. They allow you to just read the memory out of the controller. I use that a lot for like reverse engineering to see maybe there's a switch in memory or maybe a secret key for something that might be interesting for use later, things like that, like secret keys, maybe security algorithms, things like that, all that fun stuff. So it could be living in memory. Now, sometimes you need the security algorithm to ask the controller to read the memory out, which is smart. But then once you have it, maybe you can move to the next. Or you can get a factory scan tool that'll unlock it for you, and then you can just read the memory out too. So those are some of the challenges as well with it. So that's diagnostics. The other is normal mode messages. Those are the messages between the controllers that are sort of the everyday switches and things like that. What am I doing on time? Am I way over? I'm way over. What? Nobody gave me 5 minutes. Am I that far over? Am I that far over? How much do I have? How much do I have? Oh, I got 5. Okay. My timer on there is like way off. What time? How much time do I have? Okay. Just making sure. Then I'll quickly go bias. So, in the news, we'll just talk about car hacking. Got Charlie, bug bounties, just happening now. Stealing cars. You guys are interested? That people are stealing cars now with a lot of this technology. A little bit about some of the tools. Arduino has tools, Elm-based tools like the OBDII MX are really cheap. $100 can get you into it. And then some of the higher end tools like the Value Can are really nice as well. That's typically what I use. And there's another Detroit-based company as well, so that's kind of nice. We do classes and workshops, so just a little FYI. I do a class at Black Hat, DEF CON. We're doing a workshop. If you guys do need any private classes, a little sales pitch. I do private ones as well. SAE has one called the Cyber Auto Challenge, which is actually next week, or the week after next. And then, of course, CAN Bus Hack. Yeah, more interesting. And just a little another plug for everybody here, actually. We do this thing called the Car Hacking Village. This year we're doing it at DEF CON. We're working on getting it at BSides. We're also going to happily have it at GurCon, we hope, as well. So we're trying to get it we're trying to, get a lot of them out as well. So if you can't make it out to DEF CON, try to get to GurCon. We'll have a smaller version of it. Derby as well. We're trying to work on Derby as well. So we'll see. I think we got preliminary yeses from Derby. At DEF CON, we're going to have it's going to be huge. It's going to be 5,600 square feet of space. And we actually have Chrysler and Delphi. Delphi, as of yesterday, has agreed to sponsor. So they're going to be in the space. They're actually they're going to bring their controllers, set them on a desk, and say, hack it. And then they're going to bring a car into the space and say, here, you can plug in. We don't mind. What are you going to do? Well, what's the big deal? So, if you're coming out to DEF CON, definitely stop by the Car Hacking Village. It's going to be loads of fun. Loads of fun. So we're also doing a workshop at DEF CON as well, so if you want to do more hands-on, it's going to be on Friday, the first day of DEF CON in the morning. I don't know how you sign up yet. We'll do talks, turbo talks, 15-minute drop-in sessions. We're going to do village talks. We're going to have some really interesting talks. Go to carhackingvillage.com for a list of that. We have a buck hacking zone, and we have a CTF. And the guy who's running one of the guys who's working on your CTF here is going to be running that CTF there. So it's going to be cool. So you know how cool it's going to be because he's there. And then if you have any questions, that'll be it for me. So if you guys have any questions, feel free to ask or come up, whatever you want to do. So thank you for your time, and hopefully you guys start hacking. Hopefully. Thank you.